Whoa, cool. It was cold though and wet. I bet that doesn't make hunting fun when it's cold and wet and gross out. All right, beautiful ladies and gentlemen. I think you need. Yeah, here you go. There you go, my dear.
Thank you.
Yep. There you go. Okay, here we go. Today we are talking about monomials. Mano y mano means one-on-one, right? In Spanish, mano y mano, one-on-one. So monomials mean one term, okay? Just like we talked about poly meaning many, monomial means one term. Monomial. That was, there we go. Messed that up. One term. So a monomial is a number, a variable. And what are variables? It's like the X, yeah. It's the letters. It's the X. It's the A. It's whatever the letter is. A variable or a product of a number and variable or variables. So we put a little parenthesis S there because it might be one variable. There might be A's and B's there. So it's a product. And so, for example, we might have just a plain old number like -7. We might just have a plain old letter like X, or we might have something like 2XY, where it's a product, and I know it's a product because these things are just stuck right next to each other, and anytime they do that, there's a multiplication in between. So something like that. All of these are examples of monomials. Now, monomials with the same variables and exponents, really important here that they have all the same letters and exponents, are like terms. So we're starting real easy again. We are adding and subtracting monomials. So to add or subtract monomials, all we have to do is combine like terms, which you guys are already good at. Combine like terms. And like terms have the same letters and exponents. They have to match. And we do not change those letters and exponents. They stay exactly the same. And so we want to add or subtract the following monomials. We have lots of monomials here. Let's see. 4x's plus 5x's is how many x's? 9x's. That was easy. Here we have 12ab's minus 2ab's. Negative 12ab minus 2ab's. Negative 14. Very good. Negative 14ab's. We can think about that a couple of ways. We can start at negative 12 and we're going to move left 2 more, which would put us at negative 14. Or we can say, hey, they're on the same team. We've got 12 negatives and 2 negatives. They join forces to give us 14 negatives, okay? Let's see. Oh, let's look at number 4. I don't like double signs. What is minus a negative there? It's really just a plus sign. So we want to clean up those signs. Negative 8k plus 8k. Ooh. Who wins here? 0 neutral. Everybody dies here. Oh my God, it's a sad day. Negative 8k and positive 8k. They eliminate one another. There's nothing left there. All right, let's look at here, number 5. Negative 3. Look at that. See how we have r squared s and r squared s? They have the same variables and exponents. So negative 3 r squared s's plus 11 r squared s's. Are they on the same team or are they at war? War. Who's going to win? Positives by how many? 8. Very good. Positive 8 r squared s's. Do we change the letters and exponents? No, No, they stay exactly the same. When we're adding and subtracting, all we're doing is adding the coefficients. All we're doing is adding the numbers in front. All right, here we got number 6. 10 PQRs plus a PQR. 1, yeah, there's a 1 in there. We can put a 1 in front. So 10 PQRs plus 1 PQR is 11 PQRs. Very good. All right, let's get down to number 10. Now we have to figure out which ones are like terms. I have an 8xy. What's its like term? A negative 5xy. Very good. 8xy's and a negative 5xy. Who's going to win? Positives win by how many? 3. So positive 3xy. Very good. Let's see. We have a negative 2x, a negative 2x, and a positive 8x. Who's going to win? Positives win by how many? Positive 6x's. Very good. And then what do we do with our little lonely 3y here? Yeah, he's just a positive 3y. We're going to tack on the end there. That's totally fine. Let's look at number 14. Number 14, I have, what's the number in front of a squared b squared? A 1. All right, so we got 1a squared b squared. And what does that combine with? 3a squared b squared. So positive 1a squared b squared and positive 3a squared b squared is? 4a squared b squared. Beautiful. Then we have a positive 9ab and a negative 12ab. Who's going to win, positives or negatives? Negatives by how many? Negative 3ab. Beautiful. That is done. Number 16. Number 16, subtract minus 4xy from 2xy. How should we write this mathematically? What should come first? The 2xy has to come first, and then we have to subtract the negative 4xy. This is a turnaround phrase, so it's really important we get it in the right order. What do we do with our minus and negative there? Yeah, minus a negative is really a positive. We can think negative times negative is really positive there. All right, so 2xy's plus 4xy's is 6xy's. All right. Who has a question for me on combining like terms? This is really easy, right? Adding and subtracting, super simple. Okay, we're good at that. Been good at that for a week now. All right. So turn the page. Adding and subtracting is really easy, but multiplying gets a little more challenging. So we are multiplying monomials. So you can see if you look through this page, we see stuff like 4 to the 3rd times 4 to the 8th, or x squared times x to the 5th. And these are exponent rules. So we're going to learn some exponent rules for the rest of this unit. And what I want you guys to do is I really want you to focus on the meaning of exponents. And so I like to start with some really simple ones here. So let's say, what does it mean if I have 5 to the 2nd? I'm going to do 5 to the 2nd times 5 to the 4th. What we want to do is I want you to tell me, what does it mean when we are talking about exponents? 5 to the 2nd power, what does that really mean? 5 times 5. It's 5 repeated 2 times. Very good. And then what does 5 to the 4th really mean? 5 times 5 times 5 times 5. Yeah, 5 repeated 4 times. And so if we expand it, now we see that we have 5 repeated how many times? How many times? times. Yeah, 1, 2, 3, 4, 5, 6. So this is 5 to the 6th power. So if you understand what exponents really, really mean, then we can develop some rules that work every single time. Instead of writing everything out, how do we get the 6? What's the easy way to get this power of 6? Add the 4 and the 2. All we have to do is add the exponents. And that is our first exponent rule, which we call the product rule. So we're going to write this down. Here we have the product rule. The product rule. If two things have the same base, so let's say we have a to the m power and a to the n power. They have the same base. They match. And here we have the same base of 5. If your bases match, then all we have to do is keep the base exactly the same and add our exponents, m plus n. That is the product rule. All we have to do is add the exponents. So I like to write that out in words. If the bases match, then add exponents. That's all we have to do. If the bases match, add the exponents. Okay? Do we change the base number? Did I change the 5? No. The 5 stays exactly the same. So we want to find each product and express the final answer using only positive exponents. All right, do our bases match? Yes, they do. So the base stays the same, and what do we do to our exponents? Add the exponents. So we have 3 plus 8 is 11. This is a great answer. It's a lovely answer. It's a huge answer. We can see 4 to the 11th is 4,194,304 is a huge number. Would you rather write that, or would you rather write 4 to the 11th? 4 to the 11th. That number. Yeah, no way. All right, let's look at number 18 here. What's our base? -7. That base is going to stay the same. It's also in parentheses, so I want to keep it in parentheses. I do not want to change it. What do we do to the exponents? Add the exponents. Add those exponents. 4 plus 5 is 9. This is a great answer. We're going to leave it just like that. Number 19, what's our base? The base is 2. It stays the same. Now, we add our exponents. -6 plus 2. What is -6 plus 2? -4. Very good. Can I leave this like this? No, we want only positive exponents. So I need to do one more step here because my exponent is not happy. This is a sad exponent. Where does he want to go? Go down below under the denominator there, into the denominator. So we do 1 over 2 to the 4th, which is a very happy answer. 1 over 2 to the 4th. All right, what about, what's the exponent on number 20? There's a 1. It is 15 to the 1st. Everything always has an exponent. It's important you understand that. There's a little exponent of 1 there. Our base is 15. It stays the same. And what should our new exponent be? 7. 1 plus 6 gives me the 7. So 15 to the 7th power. Is this easy or hard? Is it pretty easy? Okay. Let's do number 22 here. What's our base? -1, and it's in parentheses. I want to keep it in parentheses. And we're going to add our exponents. So this is tricky. -2 plus a -3. We're adding those exponents. What is a whole bunch of negatives? -5. Very good. Can I leave this answer? No, we want positive exponents. This is unhappy where he is, so what does he want to do? Go down underneath to a denominator. So it becomes the -1. The base stays the same. It's still a -1. But what's my new exponent? 5. It's a happy 5, a positive happy 5. Okay? All right. Good so far? Yeah? Okay. So the same is true when we have variable bases. If the bases match, like here on number 23, x and x, the bases stay the same. What's our new power? 7. Very good. Number 24, do the bases match? Yes, they do. The base stays the same. Now, we have a -1 plus a 3. We got to add those exponents. What do we get? +2. Very good. And that is a lovely answer. Ooh, let's look at this one. Do the bases match? K stays the same, and we're going to add -7 plus 7. What is -7 plus 7? 0. What is any number to a power of 0? 1. Very careful. That's a good one right there. Anything to a power of 0 always equals 1. Let's look at number 26. I'm missing an exponent. What is it? There's a 1 there. Very good. Now, all the bases match. We have a base of A. What do I do to their exponents? Add them up. 1 plus 3 plus a -9. Let's see, I'm going to put my positive things together. That's 4 plus a -9. Who's going to win? The negatives are going to win by how many? -5. Can I leave this answer? No, is unhappy where he is, so what should we rewrite it as? 1 over a to the 5th. Beautiful. Okay, let's do number 28, because this one is also a little bit different here. Number 28. I'm missing some exponents. What's the exponent here with the S? A 1, and here's another 1. So we have to be a little bit careful because we can only combine things that have the same base. So I have S to the 1st times S to the 1st. What's that going to be? S to the 2nd power. 1 plus 1 is 2. And then I have R to the -2 times R to the -4. So my bases are, what do I get when I add my exponents? -6. Very good. And that's not a happy answer. Is the S squared happy? Yeah, the S squared is happy. He's going to stay on top. What does the R want to do? What does the R want to do? Go down to the denominator. So this becomes R to the happy 6th power. All right, any questions on those? No, pretty good? Pretty easy? Okay, so now we sometimes have coefficients and variables, and so it can get a little more complicated. But what I want you to remember here is that when we look, this is a 5 times an m times a -3 times an m squared. Everything is being multiplied. And so when you see parentheses, you've got to ask yourself what's really happening here. It's just a big giant multiplication problem. So we can multiply our numbers together. So I have a 5 times a -3. What is 5 times -3? -15. And then my variables, I have m to the 1st power times m squared. They have the same base. What do I do with my exponents? Add them. So 1 plus 2 gives me 3. So -15 m to the 3rd is a beautiful answer. Okay? Let's look at number 32. again, I like to sort of stretch everything out because I think it makes our life a little bit easier. I have an 8 times p to the negative 5 times 2 times p to the negative 1 times p to the first power. So I can stretch everything out. Everything is just multiplication. And I'm going to multiply my numbers together. I have an 8 times 2. What's that? 16, yeah. 16. And then everything, all the variables are p. They match. They have the same base. And I need to do something to their exponents. Let's see. A negative 5 plus a negative 1 plus a 1. What is that? Just negative 5. Yep, the negative 1 and positive 1 undo one another. So we just are left with negative 5. Is he happy? No, not happy. Not happy in its current form. Is the 16 happy? Yeah, the 16 has its own little exponent of 1. He's happy up top. And the p to the negative 5 wants to go to a denominator and become p to the 5th, where he's nice and happy now. Okay. How are you doing? Good. Okay. Let's look at 36 and then and maybe 38 and we'll be done. So once again, there's a lot going on here, but it's one just giant product. Everything is multiplied. So I can think about this as a negative 1 times a times b. You'll notice I took the negative 1 off and thought about it as a number. Just a negative 1. And then I have times 4 times a to the 8th times b to the 2nd times 7 times a to the 1st power times b to the 6th power. So I'm stretching everything out and giving everything its own little exponent. And now we can multiply all the number things together. So I have a negative 1 times 4 times 7. What's 4 times 7? What's 4 times 7? 28. With a negative 1? Negative 28. Very good. Now, I have a bunch of things that have a's. This is a to the 1st power, a to the 8th power, and another a to the 1st power. So it's a to what power? 16. Ooh. I have a to the 8th, and then I have a to the 1st, and a to the 1st, which would be... a to the 10th power. Very good. Yes, 1 plus 8 plus 1. It's important we understand that the 6 only is touching the b, and the a has its own little one up there. Yeah? All right. And then we have a b to the 1st power. There was invisible 1 there. B to the 1st power. We have a b squared, and we have a b to the 6th power. That's going to be b to what power? 6, 7, 8, 9? 9. B to the 9th. Adding those exponents, 6 plus 2 plus 1 gives me that 9, okay? Do you have questions for me? No? All right, last one here. Why is 38 different? $37 is a subtraction in it. Very good. This is a tricky one. We actually have 2 terms here. I have a first term and I have a second term. We have 2 terms. So what I have to do is I have to clean up this first term, and I have to clean up this second term, and then maybe I can combine like terms. This is a different question, so we have to do a little bit of work here. So my first term here, I'm thinking this is 9 times m to the 6th times 2 times m to the 1st times n to the 4th, and I want to clean that up. What is 9 times 2? 18. And then I have m to the 6th times m to the 1st. What's that going to be? M to what power? M to the 7th. Ooh, girls, I don't know if this seat's going to work. And then into the fourth is just going to hang out on the end. I have nothing to combine that with, so that's my cleaned up first term. Now my second term, I'm seeing us subtract 4 times m squared times n cubed times 3 times m to the 5th times n. So I've got us all stretched out. And again, I want to multiply my number things together. We can think about that as a negative 4 times a 3. What's that going to be? A negative 12. And then I have m squared times m to the 5th, which is m to the 7th power. Very good. 2 plus 5 gives me 7. And I have n cubed times n to the 1st power, which is n to what power? N to the 4th power. Very good. Now, these are like terms, so that's what we started with. They have the same variables and the same powers. They match. So 18 m to the 7th n to the 4th minus 12 m to the 7th n to the 4th is 6. 18 minus 12 is 6 m to the 7th n to the 4th. And that is our final answer there. M to the 7th times n to the 4th. 6 of them. Okay? Those are really hard to see. How do you feel about this? Do you feel okay? Yeah? Okay. Super.